last video to study is on mutations. If I had to give you a quick definition for everything, it would be a mutation is a change. Now, mutations can be good or can be bad. Okay, they're good if they help the organism survive. Okay. And then what's going to happen is the organism survives better, and then those genes get passed on, and that's how we evolve. Okay. Now, most of the time mutations are bad. It's because if the DNA is mutated, the RNA is mutated, the amino acid is wrong, and then you get a protein that instead of the amino acid chain folding into a nice protein, it kind of clumps up and it cannot do the same job as if the amino acids were all correct. Okay. Now there's 4 mutations that we need to talk about: silent, insertion, substitute, and deletion. Okay. A silent, just like its name, silent, you don't even know it's there. Okay. So we're going to see a silent mutation on the next page. So this is same amino acid sequence. So you don't even know it's there. Okay. An insertion adds a nucleotide. And when you add something, you increase the length and you shift everything over, and it affects many amino acids. Same with deletion. You delete a nucleotide, moving everything over and changing the length and a lot of the amino acids. Okay. A substitution is where if you have a sequence, A, T, G, one of the nucleotides just gets substituted for another one, an incorrect one, so it'll be like A, T, T. Okay. And then these two I want to mention, an insertion and a deletion. When you insert something, you shift everything over. When you delete it, you shift everything over. These also can be called frame shift mutations. Okay, so let's do these examples. Okay, so what I did was I made these sentences, okay, at the top. The top row are sentences broken down to 3 little words similar to codons. The bottom is the same with a mutation inserted in bold. Okay, so the sentence for number 5 is supposed to say, the fat cat ate the rat. But there's a mutation right here where a B is substituted for A. Okay, so describe the bolded mutation. B sub for A. Miss Feist. Hey. Yep, just call me so I know. Okay, perfect. Huh. Yeah, just give me a call so I know, okay? Okay, bye. Sorry about that. Okay. What did it do to the sentence? Well, I can't read the word fat. It changed the word fat to fabata, okay? But the cat ate the rat, that's still good. How many codons does this affect? This affected 1 codon, okay? And what is this mutation? A B was substituted for A. This is called a substitution, okay? Next one. The fat cat ate the rat. Okay, a B was inserted, And if I insert a B in front of the A, because codons are 3 bases long, the T gets kicked over here. And then this T gets kicked over here. And this E gets kicked over here. Okay, so ready? Instead of the fat cat ate the rat, it's the fuba tuka tut t. So as you can see, I can't even read it. Describe the bolded mutation. B added. Okay, what did it do to the sentence? It messed up all words after insertion and included where it was inserted. Okay, how many codons did this mutation affect? Well, I can't read this one anymore. Can't read this one, this one, this one. 1, 2, 3, 4, 5, and maybe even 6 right there. 5 to 6. Okay, what kind of mutation? It was an insertion. And remember, based on the other page, it could also be called a frame shift. I shifted everything over one. Okay, next one. The fat cat ate the rat. Okay, I'm going to delete the A. Now this codon is only 2 bases, so the C has to move over. Then this is only 2, so the A has to move over. So everything shifts over this way. So describe the bolded mutation below. A is deleted. What did it do to the sentence? It messed up everything after the A. So changed the fat codon and everything after. Okay. How many codons did this affect? Well, that no longer says fat, no longer says cat. Okay, so 1, 2, 3, 4, 5 are affected. And what kind of mutation is this? This is a deletion. And frame shift also. Everything shifted that way. Okay, last one, and this is the best mutation to have. Okay, so we'll pretend that we put it in the amino acid chart, the codes for leucine, fat codes for methionine, cat codes for histidine, AT8 codes for asparagine, the serine, rat, phenylalanine. Okay, so I'm going to replace FAT with FTT. Now, even though it did change a base, so this is a substitution, when I put it in the amino acid chart, it still codes for methionine. So my original amino acid sequence, lu, met, his, asp, sur, phi, lu, met, his, asp, sur, is the same. Okay, so describe the mutation below. Is sub for A. What did it do to the sentence? Well, it did change the sentence, but it did nothing to the amino acid sequence. Okay, how many codons did it affect? Well, no amino acid codons. And what kind of mutation is it? It's a substitution, but more importantly, it's a silent mutation. Because did anything happen? No, there was a mutation, but I don't even know because I'm still getting the methionine that I needed, even though it was a FTT, okay? And this is when you read your codon chart and it reads like leucine for one and then leucine for another one, okay? If you have a mutation where the codon switches to something that's the same amino acid, then you're gonna be fine. Real quick, I'm going to pull it up. So for example, if UUU phenylalanine was mutated to UUC phenylalanine, this is a silent mutation. Nothing would happen. But if a substitution, because that was also a substitution, if UUU substituted for changed to UUA leucine, that would be a mutation that changed one codon, okay? And then remember, if you insert a stop codon in the middle of an amino acid chain, it changes that amino acid and everything afterwards. And then insertions and deletions changed that codon and everything afterwards.